Okay, Assalamualaikum and good afternoon, everyone. So, welcome to MAT133, and this is pre-calculus. And for today, we are going to start with the chapter 1, which is coordinates, lines, and graph. Okay, in these videos, this next few videos that I will be uploading over here, I will be talking in English and also in Malay. So, just be sure about that. Okay. Right, so we'll start with chapter 1. So chapter 1 is about coordinates, lines, and graphs. So this is the longest chapter in this subject. Okay, so let's go through our introduction first. Okay, so let's talk first about the real number system. Okay, so the real number system, mostly this would not be asked in your exams, but it is very good to know, okay, about this real number system, which we will talk about the classification of numbers. Okay, so there are multiple types of numbers that we will be dealing with in this subject. So the first one is what we call as the natural numbers. So what are natural numbers? Natural numbers are the numbers that we are using to count. Okay, so for example, we have 1, 2, 3, 4, and so on. So this set of numbers we call as the counting numbers or natural numbers. Second, we have the whole numbers. So what are whole numbers? Whole numbers is just zero with counting numbers. It's just an additional zero on top of the natural numbers. So what we can see here is that the natural numbers is the subset of whole numbers. Okay, so n is a subset of whole numbers. Okay, natural numbers are a subset of whole numbers. And then we also have integers. So what are integers? Integers are whole numbers with addition of negative counterparts. So it will be from negative infinity, include up until -2, -1, 0, 1, 2, and up until infinity. Okay, so all of this we call as integers. Okay, in Malay we call as nombor bulat yang dah bercampur dengan negative part. Okay, so next is we have rational numbers. Okay, so what are rational numbers? So rational numbers are numbers that can be written as a fraction. Okay, if you have any numbers, okay, on top and at the bottom here of a fraction, so this number is what we call as a fraction. So 2/3, -4/5, 3. So why is 3 is a rational numbers? Because 3 can also be written as 3/1. Okay, so this is also a rational number. 14/6 and so on. Okay, any numbers that can be written as a fraction, we call it as rational numbers. Okay, ratio. Okay, the word here is ratio. Okay, so ratio is something over something. So that's what we call as rational numbers. So what are irrational numbers? Okay, on the other hand, irrational numbers are numbers that cannot be written as fraction. Okay, there are numbers that cannot be written as fraction. For example, we have this √3. So √3 is, if you press your calculator, it will become 1 point. Actually, let me just double check. So √3 is equal to 1.732050800757, so on. Okay, so this number we cannot write it in terms of fraction. There is no equivalent fraction that will result in this number. Okay, √3. So this is what we call as the irrational number. Okay, non-repeating decimal. For the fraction earlier, okay, for example, here we have 2/3. So 2/3, if we write it as decimal, it will become 0.66666 and so on. Okay, so this number behind here, okay, is repeating. But here we have non-repeating numbers after the decimal. So it means that it cannot be written as fraction. The same goes for pi over here. So we know that pi is equal to 3.1415. So okay, if you press your calculator, press pi and then click tap on the equal signs, it will become 3.141592653 and so on. Okay, this number behind after the decimal point is not repeating, so that is irrational numbers. Okay, so one thing that you might have realized, okay, so as we said earlier, so natural number is a subset of whole numbers, and then whole numbers is also a subset for integers. Okay, why? Because this 0, 1, 2, 3, 4 is a subset of this integer. Okay, and then same goes for here, 1, 2, 3, 4 is also a subset of this thing. And integers are also a subset of rational numbers. Okay, these whole integers are subset of rational numbers, because every single integer we can write it as rational numbers. Okay, as we say here, so 3 we can write as 3 over 1. Okay, and then -2 we can write as -2 over 1. Okay, so our integers are a subset of rational numbers. But irrational number, okay, rational number and irrational number are two opposite things. Okay, why? Because rational number we can write as fraction. Okay, irrational number we cannot write as fraction, so they are not a subset or something like that. Okay, so they are opposite. Okay, so that is about the classification of numbers. Okay, as you can see here, as we discussed, so natural number is a subset of whole number. Whole number is subset of integers. Integers is subset of rational numbers. But rational numbers are not a subset of irrational numbers. Okay, they are two separate things. Okay, and both of it is in the real number realm. Okay. Right, so let's talk about real number lines. So what are real number lines? So real number line is a representation of all real numbers arranged in order in a straight line. So how we usually write it is that we start from the lower value at the left side, and then we arrange it to the right, and then to the right we have a higher number. Okay, so smaller on the left, higher on the right. Okay, same goes for here. So negative 0.6 at the left, and then we arrange it, and then bigger to the right, and so on. Okay. Right. So let's talk about inequalities. Okay. This is the main focus of these few chapters. Okay. So inequalities. What are inequalities? Let's talk about it first. So mathematical expression used to compare two values. Okay. So if we have two values, for example, if we have apple, okay, so this is apple, and you also have orange. Okay, if you want to say you like apple more compared to orange, so how can you say it in terms of inequality? So if you like apple more, so you can just use this expression. Okay, so apple more than orange. I mean, this is just like to lebih kurang lah. Okay, so apple, you like apple more compared to orange. So this more than is what we call as inequality. Okay, so it can be more than, less than, more than or equal to, or less than or equal to. Okay, so to solve for inequality, the solution will be the set of numbers that satisfy the inequality. Okay, in the next video, we'll talk about how to solve the inequality. Okay, so if we solve an inequality, so you will have a set of number that will satisfy the inequality. Okay, usually you would not get like a single number if you want to solve an inequality. Okay. Okay, let's talk first about the properties of inequality. Okay, so what are the properties? So generally it follows the rule of an equation with some changes. Okay, so what are the changes? We'll talk about it in a bit. But for the other parts, for example, addition, subtraction, okay, so they are the same. For example, if A is less than B, then if we add C on the left side, you also need to add C on the right side. Okay, and then same goes for subtraction lah. Okay, so if you minus C on the left side, you also need to minus C on the left side. And same goes for if you have, for example, A, let's say more than, okay, more than or equal to B plus C. Okay, so if you want to move this to the left side, so it will become A minus C more than or equal to B. Okay, the sign here will change. So plus will become minus if you move it to the other side. Okay, so for multiplication, so need to be very careful here. Why? Because we have two different things. Okay, if you have a positive number, then it will just be the same. Okay, if you multiply a positive number on the left side, then you also need to multiply it on the right side. Okay, same thing. But if you have a negative number, okay, after you have multiplied on the left side and the right side, be sure to change this sign. Okay, change that sign. If you multiply with a negative number, or if you divide with a negative number. If it is less than over here, then you need to change it, you need to flip the sign to become more than. Okay, so here less than, if you divide with negative number, it will become more than. Okay, so less than will become more than will become less than, more than or equal to will become less than or equal to, and less than or equal to will become more than or equal to. This is only for if you multiply or divide with a negative number. Okay, it will change if we are multiplying or dividing with a negative number. Only if you multiply or divide with a negative number. Usually students will forget this one. Okay, so after you answer your question, make sure if you multiply or divide with a negative number, make sure you change your inequality sign. Okay, usually this is where the students will somehow miss to change this inequality sign. Okay, so notation, we talked about this before. And so this one, if we wrote it as 3 less than x less than or equal to 8, it means that this x is between 3 and 8. Okay, so let's talk about this for a bit. So 3 less than x less than or equal to 8. So let's separate this. We can separate it. So 3 less than x means that 3 less than x. What this is mean? It means, I think it will be better for you to understand if I write something like this. So 3 is less than x. So it means that x is more than 3. Okay, just remember 3 is less than x. For example, 3 is less than 5, right? So we can also write it as 5 is more than 3. Okay, so I just rearrange this thing. So same goes here. So if 3 is less than x, it means that x is more than 3. And same goes over here. So here, x is less than 8. So you'll have x that is lesser than 3, but sorry, x is more than 3, but at the same time, x is lesser or equal to 8. Okay, so that means x is between 3 and 8 with 3 excluded. Okay, so this is just for you to understand what does this actually mean. Okay. Right, for interval, round bracket if the number is not included, square bracket if the number is included. So you can write the inequality, okay, if you have something like this. So if you don't want to include 3, we use round bracket. So round bracket 3 and 8. So since our 8 is included, okay, because we have less than or equal to over here. So if we include 8, so we use square bracket on the 8 side. So this means our x is between 3 and 8, but 3 is not included. Okay, 3 is not included. But one note is that for infinity, okay, for infinity we always use round bracket. So round bracket negative infinity and also round bracket positive infinity. And we can also combine our intervals using the union symbol. Okay, so this is the union symbol. For example, if you want to talk about the range of x between negative infinity up until 2 included, and also 6 excluded up until positive infinity, so we can link it using this union symbol. Okay. And lastly is we have real number line. So what is real number line? So real number line, we talked about it before. Okay, but here we want to denote where the values of x is. Okay, so for example, if we have x is more than 1, so this is just x more than 1. It's not x more than or equal to 1. So here, if x is more than 1, so 1 is not included. Okay, so if 1 is not included, so we use just this white dot, just the circle. Okay, put a circle at the top of number 1. Okay, and since x is more than 1, okay, x is more than 1, which means that the values of x is higher than 1. So if it is higher than 1, so all the values of x will be on the left side. So you can just draw an arrow and then pull it and then just denote it to the right side. Why? Because our values of x is higher than 1. So just do a number line 1. So 1 is not included, so just do a circle, and then since x is higher than 1, so just draw an arrow to the right. So here we have 1 is less than x, less than or equal to 5 over 2, which means that our x is between 1 and 5 over 2. Okay, for 1, okay, the inequality sign over here is less than, so it means that it is not included. So above 1 over here, you can just draw a circle. And then x is also less than or equal to 5 over 2. So above 5 over 2, you can just use this black dot. Okay, use a black dot over here. Why? Because 5 over 2 is included. Okay, why included? Because we have less than or equal to. Okay, since x is between, okay, since x is between 1 and 5 over 2, so we just link these two together. Okay, do not, okay, this is wrong, do not do something like this. Okay, 1 5 over 2, okay, you know that this is not included, this is included. Okay, but don't do like this. Okay, this is wrong. Okay, why? Because our value of x is between, okay, between 1 and 5 over 2, so it should be over here. Okay, not over here. This is wrong. Okay, so the values should be between these two numbers. Okay, and number 3, okay, if we have our union like this, so x is less than 1 over 2, sorry, x is less than or equal to 1 over 2, so less than or equal to, so it means that we include 1 over 2, so we use a black dot. And x is more than 3 over 2, so more than 3 over 2, we use white dot like this. Okay, so x is less than or equal to 1 over 2, so since it is less than, so less than, we need to draw an arrow to the left. Okay, so to the left like this. And x is more than 3 over 2, so this one we need to draw an arrow to the right. Okay, so see the difference between these two. Okay, this one, for this one, the value of x is in the middle of 1, sorry, is between 1 and 5 over 2. And for this one, okay, our values of x is actually less than 1 over 2 and also more than 3 over 2. So there are no values of x in between these two values. Okay, that's why the arrow is like this. Okay, right. Just one more thing. Okay, those we also have set builder notation. Okay, you can also write your answer as a set builder notation. Okay, for example, if you write something like this, so you use this curly bracket. Okay, curly bracket. So curly bracket x such that x is between -1 and 1. Okay, so -1 is included and 1 is excluded. Okay, for example. Okay, so this is how you can write your set builder notation. You can also write something like this. Okay, to show that x is between -1 and 1 and -1 is included. Okay, so this is the summary for inequality expression. So you can just go through this, but the more exercise that you do, I think you'll become more familiar with all of this. Okay, right. You can try this yourself first, and we will continue on the next video. Okay, so next video we'll talk about how to solve the inequality. Okay.